On January 3, 2026, Vitalik Buterin posted a roadmap update that shouldn't be physically possible. For 10 years, this entire industry has been governed by a single unbreakable law, the Blockchain Trilemma. It says you can be fast or you can be secure, but you can never be both. It was supposed to be a fundamental law of computer science, like gravity. But as of this week, that law is dead. This is the story of the 10-year war to save Ethereum, the civil war that almost killed it, and the 30-year-old math that finally solved the impossible, the 10-year war. To understand why this update is historic, you have to understand the trap Ethereum was stuck in. When Vitalik launched Ethereum in 2015, he made a very specific trade-off. He decided that in order to be decentralized, every single computer on the network, called a node, had to process every single transaction. Think of it like a classroom. If the teacher asks a question and every single student has to stand up and shout the answer before the class can move on, the class is going to be incredibly secure. Everyone knows the answer, but the class was also going to be incredibly slow. This was the world computer model. And for a decade, it hit a hard ceiling. 15 transactions per second. That's it. That is the speed of a pocket calculator from 1990. And this is where the civil war began. New competitors like Solana looked at this model and said, "This is ridiculous." They argued that the trilemma was a fake constraint. Their solution was simple: make the computers bigger. If you require every node to be a supercomputer, you can process thousands of transactions per second. This is the monolithic philosophy. It's fast, it's cheap, and for the last 3 years, it looked like it was winning. By late 2025, the narrative was brutal. Ethereum was being called dinosaur tech. Users were migrating to faster chains, and the Layer 2 ecosystem, which was supposed to fix the scaling problem, had become a fragmented mess of bridges and broken user experiences. Critics argued that Vitalik had over-engineered the system. They said he was trying to solve a physics problem that didn't need solving. But while everyone was fighting on Twitter, Vitalik and a rogue team of researchers were quietly building something in the background. They weren't trying to make the computers bigger, they were trying to change the math. And on December 3, 2025, with an upgrade codenamed Fusaka, they flipped the switch, the Fusaka paradigm shift. So, how did they actually do it? The answer involves 30-year-old math and a radical change in philosophy. On December 3, 2025, the Ethereum network initiated a hard fork, codenamed Fusaka. For the average user, nothing seemed to change. But under the hood, the entire engine of the blockchain was swapped out while the car was still driving. Before this moment, Ethereum operated as a world computer. If you ran a complex problem, thousands of computers around the world had to run that exact same problem to make sure you weren't cheating. It was secure, but it was incredibly inefficient. Vitalik's new roadmap flipped this on its head. He declared that Ethereum is no longer a world computer, it is now a world verifier. Here is the difference. Imagine you are a math teacher grading a test. In the old model, to grade a student's work, you had to redo every single step of their calculus problem yourself. If the problem took an hour to solve, it takes you an hour to grade. You are the bottleneck. In the new model, the student does the work, but they also provide a mathematical proof that their answer is correct. This proof is like a magic key. You can look at the proof and in milliseconds know with 100% certainty that they didn't cheat. You don't have to redo the work, you just check the receipt. This is the breakthrough. By January 2026, the technology to generate these proofs, called ZK-EVMs, became fast enough to run in real time. 2 years ago, generating one of these proofs took 20 minutes. As of this week, it takes less than 16 seconds. This means the network can now offload all the heavy lifting to supercomputers, while the decentralized nodes just check the receipts. The result? The security of a decentralized network, but the speed of a centralized server. The trilemma didn't break, we just found a way to cheat the system. But saying you solved it is one thing, actually making it work with 100,000 transactions per second is another. To understand how that is possible, we have to look at the engine itself, and specifically a technology called PeerDAS. The engine room. Technical deep dive. The jump to 100,000 transactions per second is powered by two specific engines hidden deep inside the code. Engine number one is called PeerDAS, and the best way to grasp this concept is to think of a hologram. In the old Ethereum, if you wanted to store a 1 GB block of data, every single node had to download that entire 1 GB file. If they missed even a single byte, they would reject the block. This is why we couldn't have big blocks. It would crash the network. PeerDAS changes this using something called Reed-Solomon erasure coding. This is the same technology NASA uses to send photos from Mars. It takes a block of data and expands it mathematically into a larger set of data. Here is the magic part. Because of the math involved, you don't need the whole file to reconstruct the data. You only need 50% of the pieces. Any 50%. It's like a hologram. If you cut a hologram in half, you don't see half the image. You see the whole image, just slightly fuzzier. So now, instead of downloading the whole file, the Ethereum nodes just sample it. They ask for 30 random tiny chunks. If they get those 30 chunks, they know with statistical certainty that the rest of the data is there. They don't need to hold the data, they just need to know it exists. This allows the network to process massive amounts of data, terabytes per second, without any single computer needing to store it all. That solves the bandwidth problem. But we still have the computation problem. Even if you have the data, you still have to process it. That brings us to engine number two, the ZK-EVM. And for this, we go back to Sudoku. Imagine I give you a blank Sudoku puzzle and ask you to solve it. It might take you an hour of brain power. That is execution, doing the work. Now, imagine I hand you a completed Sudoku puzzle and ask you to check if it's right. You just scan the rows and columns. It takes you 3 seconds. That is verification. This is what ZK-EVMs do. Powerful supercomputers, the provers, spend the energy to solve the Sudoku, processing millions of transactions. They then generate a cryptographic report, a zero-knowledge proof. They send that receipt to the Ethereum network. The decentralized nodes don't rerun the transactions, they just check the receipt. It takes milliseconds. So here is the final equation. PeerDAS gives us infinite data capacity, the hologram. ZK-EVMs give us instant verification, the Sudoku. Put them together and you get a network that is decentralized, secure, and processes 100,000 transactions per second. The trilemma isn't just solved, it's obsolete. The new problems. Of course, in technology there are no new solutions. There are only trade-offs. And by solving the trilemma, Ethereum has created two new, massive problems. Problem number one is called the sense paradox. For years, the complaint was that Ethereum was too expensive. But after the Fusaka upgrade, transaction fees on Layer 2 networks dropped to less than 2 cents. This sounds great, until you realize what happens when things are essentially free, spam. Without the economic friction of high fees, bots are now flooding these networks with millions of junk transactions. We have moved from a scarcity crisis to a glut crisis. The network is so fast and so cheap that we don't know what to do with all the data. Problem number two is fragmentation. Right now, the Ethereum ecosystem looks less like a unified country and more like a jagged archipelago of islands. You have Optimism, Arbitrum, Base, ZK Sync. They're all fast, they are all cheap, but they can't talk to each other. If you want to move money from Island A to Island B, you have to use a bridge, and bridges are where hacks happen. This is why users prefer Solana. Solana is one giant continent. You don't need a passport to walk down the street. Vitalik's answer to this is the final piece of the 2026 puzzle. It is called based rollups. In simple terms, this technology forces all these different islands to use the same shipping lanes, the Layer 1 validators. It allows them to synchronize their activity in real time. It mimics the feel of a single monolithic chain like Solana, but keeps the security of the decentralized modular chain. It is the best of both worlds, but it will likely take another 2 years to fully implement. The civilizational infrastructure. When Vitalik Buterin tweeted on January 3rd, he called this a 10-year journey, and he wasn't exaggerating. This specific architecture, PeerDAS and ZK-EVMs, wasn't just a coding challenge, it was a redemption arc. The core technology behind PeerDAS was pioneered by a researcher named Mustafa Al-Bassam. 10 years ago, Mustafa wasn't a researcher. He was a teenager in the hacker group LulzSec, taking down the CIA and Sony. He went from breaking centralized systems as a kid to building the ultimate decentralized system as an adult. And that brings us back to the start. For a decade, critics said Ethereum was trying to do too much. They said you couldn't have a network that was decentralized, secure, and fast. They were right if you tried to build a world computer. But Vitalik realized something they didn't. The world doesn't need another computer. It has plenty of those. What the world needs is a verifier, an incorruptible machine that can check the math of the entire global financial system in 16 seconds or less. That machine is finally built, but this isn't the finish line. The next phase of the roadmap, codenamed The Verge, is already starting. The goal isn't just to make the network fast, it is to make it invisible. To create a future where a node doesn't run on a server farm, but silently in the background of your smartphone. The trilemma isn't dead. Now the real work begins.